All right, so we're going to do some covalent single bonds. The first thing that you have to do is, if it's in word form, is make sure that you put it into formula form. Carbon, tetra means 4 chlorines, CCl4. Okay, and so now I'm going to do the individual electron dot. Carbon is in group 4, or group 14, so it has 4 valence electrons, 1, 2, 3, 4. Chlorine, I'm just going to draw 1 right now because I'm just trying to figure out who's my central atom, is in group 17, so it has 7 valence electrons. So those are individual electron dots. And I see that carbon has the most gaps, or the least electrons. So that means carbon is going to be my central atom because it has the most spots to fill, so I can maximize what's going on. So carbon here, I'm going to redraw with its electron dot notation, 4 dots, 4 valence electrons, because it's in group 14. And then chlorine, I'm going to put around it. How many do I have to put around? 4. So there's 4 sides. So I'm just going to write 4 sides. Okay, and I'm going to use X's for this guy so that it doesn't get confused with the dots of the carbon. And chlorine, again, is 17, so 7 valence electrons, so it has 7 dots. And you're going to follow the same normal structure format. Don't worry if your gaps are not lining up with your other electrons, because this next stage is we're just showing the process here. Okay, so electron dots by themselves, and then the process. And then we'll do redraw for the final. Okay? So to make single bond, a single bond is 2 electrons. Okay, and they get connected together with like a bar. I just call that a bar, and that is that single bond. But we got to figure out those 2 electrons. Okay, you can't just take 2 electrons from chlorine because he's not bonding with himself. You got to take 1 electron from chlorine and 1 from the central atom. So that would be 1 single bond. That would be 1 single bond. That would be 1 single bond. And that would be 1 single bond. So carbon has 4 bonds, 1, 2, 3, 4. There are 4 single bonds. Each chlorine has 1 single bond. Okay? You don't call this a quadruple bond or anything. It's carbon has 4 single bonds. Each single bond is to 1 chlorine. Okay? And then we rewrite because that's a mess. We look at carbon. Does carbon have any extra electrons? It does not in this case. So we just write carbon just like it is, and then put bars instead of those ovals. That just makes it neater. That bar still stands for 2 electrons, 1 on this end for carbon and 1 on the other end for chlorine. And now I'm going to write chlorine around. Okay, and how many extra electrons are chlorine going to have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notice I'm not putting those electrons on the bond side because the bond side is already showing as full. Okay. And now what do I check when I'm done? I check and make sure my valence numbers are still correct. Carbon has 4. 1, 2, 3, 4. 1, 2, 3, 4. Because remember, you're picturing this bond. Even though we draw it as a straight line, you can picture it kind of like a dumbbell. Okay, so carbon still has 4. Okay, chlorine is supposed to have 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So they are still meeting their valence rules. Check. And now you want to make sure they meet their octet rules. That means that they've made 8. Well, carbon has 4, but he's sharing with the other side. So he has 2, 4, 6, 8. So he's happy. He has 8. He thinks he's a noble gas. Chlorine, 2, 4, 6, 8. Thinks he's a noble gas. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. So they meet the octet rule. So that guy is good. Okay, and you don't need to show all those little circles around there. I was just showing that for you. You would actually just keep those off. Okay, carbon, Br2Cl2. Okay, well, I already have the individual carbon and the chlorine up from the problem before, so I'm not going to rewrite them. But bromine is also a group 17. So it has 7 valence electrons, 1 gap. Chlorine has 1 gap, bromine has 1 gap. So carbon, again, is going to be in the center with its 4. Bromine and chlorine, I'm not going to teach you a rule, just spread them around. Bromine, bromine, chlorine, chlorine, okay? And then add how many electron dots you're supposed to have for these guys. And again, don't worry about if they're lining up properly or not. Just get them on the paper using the format. 1, 2, 3, 4, 5, 6, 7. Okay, and then do your ovals. I'm going to single bond, single bond, single bond, single bond. Why am I not double bonding? Because chlorine only has 1 hole, so he has a maximum of a single bond. Bromine only has 1 hole. He can do a maximum of a single bond. So I'm not going to try to share multiple pairs. And now let's rewrite. Carbon, nothing else is around him, so he just has 4 single bonds. Chlorine, and then 1, 2, 3, 4, 5, 6 electrons left over. Bromine, 1, 2, 3, 4, 5, 6 electrons left over. Same with this bromine. Same with this chlorine. If you don't write those other electrons over, these are called unbonded pairs because they're not bonding, but they're still important for a reaction. So you still have to show all those pairs. So this would be carbon, dibromide, dichloride. Boron trihydride, BH3. Boron is group 13, so it has 3 dots. Hydrogen's group 1, 1 dot. Okay, who has the most gaps? Now, some people always want to say hydrogen's the most gaps. Remember, hydrogen is in period 1. He only has 2 max, so he still only has 1 gap. Whereas boron has 5 gaps. So boron is still going to be your central atom. Boron, redraw, and hydrogens draw around. Okay, hydrogens have 1 each. Single, single, single. So now when I redraw, this is who I get. Now, boron does not follow the octet rule, okay? Because he only has 3 electrons there. He's in a weird circumstance. He does not follow octet. Okay, hydrogen has 1, 2. So he's full, even though he doesn't follow octet. Hydrogen, 1, 2. Hydrogen, 1, 2. So he's full, even though he doesn't follow the octet. He thinks he's like helium, his noble gas. Hydrogen still has 1 valence electron. Hydrogen, 1 valence electron. Hydrogen, 1 valence electron. Still working well with valence electrons. Boron, 1, 2, 3 valence electrons. So he's still doing well there. 2, 4, 6. He does not follow the octet rule, so don't try to add in anything extra for boron. He is perfectly happy just like this. And our last one is water. Water is H2O. Okay, I already know hydrogen has a 1 dot from the one before, so I'm not going to rewrite that. But oxygen is group 16, so 6 dots or 2 gaps. 1 gap, 2 gaps. Oxygen has to be in the center. Okay, and hydrogen. I'm just going to put the hydrogens around and then do that process where I'm making single bonds. Hydrogen can only make single bonds because he only has 1 gap. Oxygen can make 1 double bond because it has 2 gaps or 2 single bonds. Since there's 2 hydrogens, oxygen is going to make 2 single bonds. Okay, and then we rewrite. Right, we have 4 extra on oxygen that weren't used. Single bond H, single bond H. Now let's check valence. 1, 2, 3, 4, 5, 6. Valence checks. Okay, hydrogen has 1, hydrogen has 1. And now octet, 2, 4, 6, 8. And hydrogen does not follow the octet, but he thinks he's helium with 2, so he is still good. These unbonded pairs here should stick together. So don't try to put 2 of these on the top and 2 on the bottom. They actually rotate around, so you'd see both on the top.